In this video, I just wanted to make a quick remark regarding the uniqueness of points in rectangular form versus in polar form. So when you have a point represented in rectangular form, the ordered pair and the point are unique, meaning if you choose any point in the plane, it's going to backtrace to one ordered pair, and every ordered pair will trace to one point in the plane. There's what we call a one-to-one correspondence that we have between XY ordered pairs and points in the plane. And we kind of know that. That's somewhat intuitive. We may not have explicitly said it before, but it's certainly true. You can't have the point 2, 5 being here and here, right? It's not going to be in two different locations. And then likewise, if you have some point in the plane, over here, you can't express it as blank and blank. It's going to be the same point, regardless of how you write it down. There's only one way of writing an ordered pair down to signify a point in the plane. Now, the thing is, on the other hand, polar coordinates are not unique, and this is strange. This takes some getting used to. To get right here, to get at that location in polar coordinates, there's 1,000 different ways to get right here. Let me show you what I'm talking about. See, this point here is dictated by an r and a theta. Typically, the theta will be 0 to 2 pi. But what if the theta went all the way around and then came back here and had the same terminal angle, but the same terminal angle, but a different theta, so to speak, and then the r was the same? Well, then you would still end up at the same place, but that would be two very different expressions of the same location. Okay, let's look at this point here for an example. 2 pi over 4. So let's face pi over 4, and then let's go out 2 units, and let's say we're right here. So this is 2 pi over 4. Well, if you think about it, there are tons of other ways that you could say that location. For example, you could say 2 let's see, on some scratch paper, if I did 2 pi plus pi over 4, that would be 9 pi over 4. This is obviously a different point. Just look at them. They're different order pairs here, but they're representing the same point, because all we've in effect done is taken that angle plus 2 pi and then wound up at the same terminal angle there. But we're not done. That's not the only way. You could go in reverse. You could say 2 and then back up. You could back up. Let's see, what would that be? 7 pi over 4. So negative 7 pi over 4. And 2 is still your r value. You would still wind up here. You just backed up a certain theta as opposed to going forward. It sounds like minor differences, but they're actually a big deal. All these technically are different. All right, for the last one, let's look at a real crazy one. Okay, rather than have the angle eventually pointing towards that point, what if we had the angle point directly away from that point, such as something like 5 pi over 4? So then your body is facing this way. So how on earth could you graph behind yourself and plot that same green dot? Well, you could graph an r value of -2, plot a -2 5 over 4, and you would still be right here because your body would face this direction, but since the r value is negative, it's actually behind yourself, and you still get there. So on and on. You could do hundreds more if you want to. You can go around and around, you can go backwards, you can aim in the opposite direction and have a negative r value. Whatever you want. My point is simply that there's multiple ways of expressing points in polar coordinates.